All right, we're getting started in chapter 3, which is surface area. Kind of a review. You've done surface area a number of times, different objects perhaps at different times, but we're putting it all together in this chapter 3. So the getting started just reviews some previous concepts that you've learned that will help you with this unit. So the first one is just sort of a bit of estimating. It says match each area to an object it could describe. So you want to kind of take a look at, first of all, the units. So these are metric. Oops, let me just get going here. These are metric, and these are imperial. Okay, and then what's the smallest unit? Well, a centimeter is smaller than a meter, and so centimeter squared will be smaller than meter squared, particularly with the numbers there. So that's smallest. And then square inches, that's the smallest imperial. But an inch is bigger than a centimeter, and that number's bigger. So we really want to kind of look at the smallest item here. So a postage stamp, I would say that that would be 4 centimeters squared. If you think about 2 centimeters by 2 centimeters, that's 4 centimeters squared. A postage stamp is probably even smaller than that. It's probably 1, but we have 5 and 5, so we'll have to go with that one. Okay. Next smallest is a cell phone. And so I would probably say 8 square inches. So that's 4, say 4 inches by 2 inches makes pretty good sense. Inches, there's about, what is it, 2.2 inches in centimeters in an inch. We'll look that up in a minute. And then next is a binder, 1 square foot. Yep, probably a foot by a foot, 1 by 1. That's the length of a ruler. And then now here, between meters squared and square yards, well, a square yard, a yard is smaller than a meter, and then this number's bigger. So this would be the biggest, this would be the next biggest. So the biggest here, what's left is a bed, and then a window, 1 square yard. Okay. Next one, it says evaluate, so 23.5 meters, and then you square it. So if I get my calculator out, you can go 23.5 square button. So you look for that squared button on your calculator, whatever kind you have, and 552.25. And then the units are squared. Now, this is already been squared, so that's 25 centimeters squared. That's units. It's not saying we're squaring the 25. Different from the last one, there was brackets around it. So we add those together and then square root. Okay, so when we add that, that's 169. And then the square root of 169, you might know it. It is a perfect square. It's 13, but you can use your calculator. Okay, and because those were centimeters squared, and then you're square rooting, you get back to centimeters. Okay, area of a polygon is the number of square units of space that it covers. Name each polygon and determine its area. Well, this is just a rectangle. So this is a rectangle. What is it? 5 feet by 4 feet. So in units, that's 20 square feet, or feet squared, when you remember back to 10-3 last semester, or last year. Name of polygon, this is a triangle. And area is 1/2 base times height, or base times height divided by 2. Really depends on how you like to work with it. So base times height, I tend to use a dot rather than an X so it doesn't get confused with the variable. So 6 times 8 is 48, times a half is 24. And again, units for area are centimeters squared, just like last year, year before, all that. Been doing it for a while. Next one, so on the left here on your sheet does have the areas for a rectangle, triangle, parallelogram, trapezoid, in case you forget. So the next one's a parallelogram. And the area is base times height. So that's 17. So you don't have to use brackets. 17 times 11. So make sure that you're using the base and the height meet at that 90-degree symbol. You never use this slanted height. So 17 times 11. Oops. Didn't register in my calculator. 187. And that's going to be meters squared. This one's a trapezoid, so it has just two sides that are parallel. The other two aren't. Okay, so there's the area. Sometimes I put the height of that trapezoid after the H. I tend to do that. So then I'll put that in brackets. So the height is, so you want to look at that height between the two parallel sides. So they meet at 90 degrees. So that's 6. And then in brackets, you add the parallel sides together, 18 and 8. So order of operations, this you've got to do first. That's 26. So half times 6 times 26. Well, maybe you can do it in your head. A half times 6 is 3 times 26. Or you could go 1 divided by 2 times 6 times 26. 78 no matter what. And that's inches squared or square inches. Okay, turn to the next side. You can pause the video at any time if you need to spend more time on it. Okay, circles. So circumference and area of each. So again, on the right, reminds you of the circumference, pi times diameter, or 2 times pi times radius, because 2 times the radius is the diameter. And then the area is pi times radius squared. Okay, so circumference is 2 pi times the radius, which is 3. And so that's 6 pi. So multiply those numbers, leave pi, but then multiply 6 and pi in your calculator. So 6 times, in my calculator, it's second exponent key. Okay, and then we'll round to 1 decimal place, 18.8. And it's just yards because it's just the length around it. Area is pi times 3 squared. Well, 3 squared is 9. So that's going to be 9 pi. And then what's 9 pi in your calculator? And you don't actually need the multiplication symbol. Most calculators, you can just put in 9 pi, enter. 28, we'll round to 1 decimal place, 28.3. Okay, next one is given here, the diameter. So if we use the first formula, it would just be pi times 8, which is 8 pi. And then in our calculator, 8 pi is 25.1. Okay, now for the area, we have to use the radius. And so we have to take half of 8, which is 4. So the radius is 4. And then it's pi times 4 squared. Well, 4 squared is 16. So this will be 16 pi. And then in our calculator, oops, oh, sorry, flipping back and forth here. 16 pi is 50.3. Okay, and so it just reminds you some buttons have a special pi button, and so please use that. We're not using 3.14 anymore. That was sort of an elementary school, junior high maybe, but now in high school we use pi. We want to be as accurate as we can. All right, next question. Oops, Tula works at an aquarium store. She uses area formulas to estimate how many fish an aquarium can hold. For freshwater tropical fish, the formula is area of the top of the tank divided by 12 square inches equals number of fish. How many freshwater tropical fish can live in the aquarium? So we basically need to find the area of the top of the tank first. Well, that's a rectangle. So area of the top is length times width. So I put them in brackets this time. That means multiplying as well. So 48 times 18 is 864. Okay, and so now we want to divide by 12. So actually I'll do this. So number of fish equals 800, switch that around, 864 divided by 12. So the 864 is already in my calculator. I'll just go divide by 12, and that's 72. And that would be 72 fish. That's a lot of fish. Probably depends on what kind of fish, right? And then it says Tula's aquarium on the right is 24 inches high. What is the total area of all of its outside surfaces in square inches? Include the top and the bottom. So that's what we're getting into in this unit, is calculating the surface area. So with this is a rectangular prism. And so the front and the back are the same rectangle, the left and the right are the same rectangle, and the top and the bottom are the same. So really the surface area will be 2 times, let's start with the top and the bottom. So 2 times 18 times 48 plus, let's do the front and back, 2 times. So remember this is 24 inches high. So the front would be 24 times 48. And then the left and the right would be 24 times 18. Okay, so 2 times 18 times 48 is 1,728. Plus 2 times 24 times 48, 2,304. And then 2 times 24 times 18, 864. Okay. Depending on what kind of calculator you have, you might have to add them all in, but you can take the last one and add 2,304, add 1,728. If you have a graphing calculator like this, you can go up and, depending on the version of it, enter on that value plus go up to the next one you have to add, enter on that value, plus 864, enter. Okay, so 4896, and that is square inches. Okay, so that's the end of the warm-up. Kind of gets you into surface area with this last question. So now you can start on chapter 3.1.